Good afternoon. Today we will discuss an environmental impact assessment of the new Fort Replacement Bridge or the Queensferry Crossing. The Fort Replacement Crossing, now known as the Queensferry Crossing, was a project which began construction in September 2011 and opened on the 30th of August 2017, costing the Scottish Government £1.35 billion. The bridge is over 2.7 kilometers long and spans the Forth estuary, replacing the original aging road bridge that connects Fife to Edinburgh, and also needed additional 4 kilometers of new connecting road. Being a road connection, the new bridge was considered an Annex 1 under the EU's Environmental Impact Assessment Directive, meaning that a full EIA report had to be carried out before work could begin to determine the effect construction and operation of the bridge would have on the environment. The environmental statement was published on the 17th of November 2009 and thoroughly explored in detail possible impacts and mitigation measures for the local environment, including water and terrestrial environments and environmental pollution. First, Tom Skinner will describe the predicted ecological impact.
A range of habitats surround the proposed site. They include arable lands, wetlands, grassland, woodland and freshwater habitats. Specific sites of importance surrounding the project include St Margaret's Marsh and Ferry Hill, which are both SSSIs. The River Almond also flows through the site, which is designated as an SINCS due to its salminated waters. These habitats are home to many nationally protected species, including bats, otters, badgers and crested newts. Examples of impacts highlighted as high concern to these ecological receptors include the threat of direct habitat loss, direct mortality of species, habitat fragmentation, loss of diversity, disease and alien transfer, and levels of disturbance. These can arise during construction and whilst operation. During construction, potential impacts arose due to loss of habitat and loss of fragmentation, whilst during both construction and operation, physical obstruction and disturbance from modes were identified to threaten direct mortality and behavioural change for terrestrial animals. The ecological impacts were predicted by professional ecologists who independently reviewed and assessed each ecological receptor mentioned previously. Geological research was undertaken in 2 phases. The preliminary phase 1 reviewed habitat surveys estimating the total areas and total habitat types. This was then followed by secondary phase 2, identifying all terrestrial and aquatic life of interest in the habitats from phase 1. Both phases included field research of each terrestrial and freshwater system, 500 metres either side of the proposed construction, following the best practice guide of Highways Agency. The baseline conditions were determined through desk-based studies and fieldwork with the goal of understanding the legal protection and conservation status of all the identified habitats and species. The magnitude of the impact was assessed based on a scale looking at if the impact is indirect or direct, the persistence of the impact, the frequency, duration, and likelihood of occurrence. This allowed the significance of the impact to be classified as negligible, low, medium, or significant. This was followed by an assigned value using a framework categorizing the significance of the value from highest order, international, European importance, to lowest order, local, limited ecological value. It was determined that without mitigation, the ecological impact on bats and otters was significant in accordance with SEAM guidelines, stating that the effect of these receptors was sufficiently important to require thorough assessment that adequate mitigation must be provided. The mitigation methods proposed include application of best practice guide with specific measures such as creation and enhancement of habitats through replacement and additional planting of trees. On top of this, species-specific mitigation included translocation for species where necessary to avoid negative conflict and the replacement of otter holes, badger sets and bat boxes. Finally, mammal underpasses and fencing were constructed, as well as insertion of culverts and watercourse changes in accordance with the best practice guide used. Bat species and local otters suffered from significant short-term residual impacts due to habitat loss and fragmentation, along the River Almond, Swineburn and Nidgeburn. These impacts occurred during construction due to the disturbance and severance of otter commuting routes from temporary habitat loss. There were no other significant residual impacts on any other species, terrestrial or freshwater. Finally, the EIA highlighted that the construction of the bridge will conclude in positive residual impacts also. These impacts result from provision of new river habitat along the Swineburn, where proposed realignment of the watercourse would create and improve morphological and habitat biodiversity. Resident bat populations were predicted to have long-term positive residual impacts at North and South Queensferry due to the provision of the crossing facilitating movement over the Firth.
The water environment around the Queensferry crossing is surrounded by and consists of SPAs and SACs, which are the Special Protection Areas and Special Areas of Conservation, respectively. The Firth of Forth is a very important estuarine area, and this firth houses many intertidal and subtidal habitats. These in turn support marine fauna such as migratory and non-migratory fish. In fact, 35 kilometers upstream is the River Teith, which is a special area of conservation for salmon and lamprey. The Firth of Forth also provides for benthos, sediment-dwelling organisms, marine mammals such as dolphins, whales, and seals, as well as many estuarine birds. One can see below some pictures of these animals, as well as a curlew, which is one of the estuarine birds. Many of these bird species are protected by European and national legislation. After evaluation, it was found that in the Firth of Forth intertidal habitat area, the area affected by permanent impacts was going to be small compared to the total habitat. With the constructions used to build the crossing, there would have been the loss of benthic habitats, but it was speculated that flora and fauna would recolonize and rapidly take up the habitat again. Fish and estuarine birds would also return once the construction activities would cease. The measures taken to reduce the impacts on the estuarine environment were to use the best construction techniques possible to avoid habitat contamination and pollution. This involved the use of and following of pollution prevention guides. The construction work was also supervised by an ecological clerk of works, especially during the excavation and piling activities. This also links into the next point, which was that the construction activities were regulated in terms of timing, for example, to avoid the breeding seasons for the terns in May and June. Acoustic deterrents were used to discourage sensitive species from getting into the area during key construction times. And finally, the assessments for all the environmentally sensitive and potentially impacted habitats were assessed by the Scottish ministers. The reports concluded that the internationally important sites would not be affected.
It's important to note that bridge infrastructure projects do not exclusively involve and thus impact the water environment over which they are built, especially given the scale of this development, which required the construction of two dual carriageway approach roads north and south of the bridge. Construction practices, especially the construction of large roads, is a major source of ground contamination. This can occur directly from the construction vehicles and machinery, releasing contaminants into the soil profile. These include hydrocarbons, PACs from fuels and oils, heavy metals and other inorganics from the machinery and intrusive processes. Also, this can occur through the disruption of dust and silt particles, which can pollute waterways if they enter at high concentrations. Contamination can come about indirectly during construction through soil compaction by heavy machinery and road-making processes. Soil compaction influences the way in which water and nutrients move through the soil, resulting in inhospitable soil environments for plants to grow and negatively affecting groundwater flow and further the wider hydrology of the area. In terms of air pollution, there was undoubtedly increased emission rates during construction. However, it is thought that the new bridge and efficiency of the road networks will ultimately reduce emissions as congestion will be reduced. As for other mitigation strategies, it was identified that silt contamination of watercourses was a primary concern during road construction. Therefore, the engineers involved decided to adopt the use of sustainable urban drainage systems, which are artificial drainage systems that mimic natural systems by slowing down infiltration rates into groundwater. Disruption to soil profile was somewhat counteracted by the planting of 400,000 new trees in and around the area affected by construction. Planting of new trees improved soil structure and stability.
So in conclusion, overall the EIA report managed to predict many of the major environmental issues that could have arisen during construction and operation and mitigate them quite well. For being such a large construction project, it is quite remarkable how small of an impact it had on the Firth and surrounding areas. This may be due to the highly developed nature of the site, leaving little habitat left to lose compared to sites in more remote locations. But considering the project was an Annex 1 development with numerous environmental stakeholders, potential contamination sources were under great scrutiny and thus minimized maximally during construction of the approach roads. However, long-term monitoring of vulnerable construction areas would be required to assess any compounding impacts that may arise in the future that were unforeseen and thus not initially assessed in the EIA, which applies to water, terrestrial environments, and air pollution impacts. Immediate contamination, however, did occur during construction of the bridge, where hundreds of tons of waste concrete were poured into the Firth. Occurrences like this should not happen during any project. The perpetrators responsible should be prosecuted and an assessment of the impact of this act should be conducted.